All right, so this is problem 527 from your book. Basically with this, we have a smooth uniform bar, AB, and you see it's like propped up against this wall that's at an angle. Basically, with this, we want to start by drawing our free body diagram. So we'll draw our AB. And it gives us the mass of it. So the mass would be the weight. Weight equals mass times acceleration due to gravity. And so that's 20 kilograms times 9.81 meters per second squared. So that's going to give us 196.2 newtons. So that's that weight. And then the support reaction, so at A, we have that thing sticking up, so we basically have a reaction that's horizontal. It's normal to that plane that it's touching, and then normal to the plane that it's touching in the vertical. And then for B, it's just going to be normal to that plane, so it's going to be in this direction. And let's see, we know a little bit about the dimensions and stuff. We know the weight's going to be in the center of the bar, so 2 meters, 2 meters. What else do we know? Let's see, we know that, let's see, this angle is 30 degrees. Let's see. So we know this angle right here is 30 degrees. And so this angle up here would be 60 degrees. And then for the MB, if we take this down, or yeah, the angle on the, so it's actually perpendicular to that wall that it's on. So I didn't actually draw it super well. I'm gonna redraw it. So the MB is perpendicular to that wall that it's on. And that wall is at a 60-degree angle from horizontal. So right here, color is 60 degrees. So we also know that this angle right here would be 60 degrees. And that's just to the horizontal here. All right, a little bit messy diagram. I apologize for that. So we have 3 unknowns, 3 equations, so we should be good. So we know we can sum the forces in the x direction equals 0, sum the forces in the y direction equals 0, sum the moments about some point equals 0. So let's start with summing the moments about that point A, since it's the one we know the least about, equals 0. So we have the weight, right, which is the 196.2 newtons. If we do our right-hand rule, we know that's going to be into the board, so that'll be negative. Make out of the board positive. We're going to do this. Always forget to write the coordinate system. So negative 196.2 newtons, and then we need to know that perpendicular distance. So it's times 2 meters times the sine. Wait, we're doing, yeah, the moment's about A. Yeah, due to that weight. So sorry, cosine of 30 degrees. So that's giving us this perpendicular distance to that weight. And then we have the NB, which will also influence us. So with NB, let's take the y component of NB. So that one's going to be going in this direction. And then we'll need this distance again, or this distance this time. So let's do, so NB times the cosine of that 60 degrees. That'll give us that just that y component, and then we want to multiply that by that total distance, which would be 4 meters times cosine of 30 degrees, which will give us that distance there. So that's that y component of the MB. We also need and let's do the sine of it. So that's going to be out of the board, so that's going to be plus. And then we also want to do, I'm going to do a different color for this one. We also want to look at that x component of MB. So MBX, which would be NB times the sine of 60 degrees. With that one, we go from A up to that point B. Fingers go to the right, so it's out of the board. So that's positive. Moment, and then we want to find this distance here. So that would be times 4 meters sine of 30 degrees. And that equals 0. So this is good. We've just got basically one unknown, this MB. So I want to pause it and do a calculation. So I just multiplied it out, and I get MB equals 98.1 newtons. And that's in that direction that we already talked about. And then now we can just do our other two equations. So we can sum the forces in the x direction equal to 0. So that equals AX, which we don't know, and then W is not in the x direction at all. And then that x component of the NB. So that x component of the NB is minus NB, which is the 98.1 newtons. Sorry about that dot there. And times the sine of 60 degrees. And that equals 0. So AX equals just that 98.1 times the sine of 60. So that's 84.96, so 85.0 newtons. We got it positive, so that means we were right. So it's 85 newtons, and it's to the right. And then sum of the forces in the y direction equals 0. That equals AY minus W, which is at 196.2 newtons, plus that y component of the NB, and that's 4, or sorry, not 4, what am I doing? That's 98.1 newtons, that's at MB, and then we just want that y component of it, so that would be times the cosine of 60 degrees. And so with that, we'll get AY, it's at 196.2, 98.1, 60 cosine times minus, so AY equals 147. I got positive again, so that means we guessed right, so AY is up to the right, or up. So there are all of our things. With MB, I guess we also should put the directions to be clear. So that would be, 30 degrees. So it's pointing up and to the left. And that's it.